Perfect. Here we are. Now we are, first of all, to welcome Mr. RAYL PEREZ ENRIQUEZ from Universidad de Sonora in Mexico, here in Samos for the second international festival Pythagoras. Welcome. Thank you very much for joining us.
Thank you very much, Frosine. I want to thank you all, the committee organizing for the second festival, International Festival of Pythagoras. This event that is going to take here in Samos, I want to present my presentation that is going to be about the Gnomonic Factor and the Pythagoras.
Thank you very much.
I will share with you my presentation. This is my presentation, then I will follow the script. The aim of my talk is to try to convince you that there are new tools in the ancient facts of science, data, and field in the field of astronomy. In particular, the Gnomonic Factor could help to discover information that was hidden in the past, but will bring new light on philosophy and evolution of mathematical knowledge. Also, it could give some ideas about how people like Pythagoras arrived to complex thinking, as it was the theorem that made him famous. We can say a few words about Pythagoras, but as it was very soon that he became a leader of a sect, religious sect, then many of the facts are combined with ideas of the legendary person that became very famous. It seems that he was born in Samos, in the island of Samos, and that he spent some part of his youth in that island. Around the execution of Polycrates, it was leaving that island and to other places. One of the main contributions of the Pythagoras was the formulation of the mathematical theorem that relates the hypotenuse with the size of the square rectangle. This fact is that it is attributed to Pythagoras not because he was the first, because some documents and traditions tell that the 3-4-5 triangle, for example, was known as for Egyptians and in China or Mesopotamia, including in India. But the important thing is that Pythagoras could have learned about this, and he could have the initiative to convert this in a general knowledge mathematical theorem. How was the Pythagoras way to know this was an important theorem? It is unknown. We don't know about the details of how his mind came about this, but we have sufficient in facts that there is a present knowledge, knowing as the numbers are behind the essence of all things intelligible to the senses. This idea basic was promulgated by his school and let us know about this important knowledge. How this way could have been, I'm going to try to present the concept of mnemonic factor in the light of two new sciences that are growing each day, the archaeoastronomy and the cultural astronomy. These both sciences let us know that many facts that are not written but are embedded in the sculptures or in other methodologies can show us the history of itself. Joseph, in his book in the 2010, gave us an idea that it is an unnecessary restrictive way to have confining ourselves to written history of the mathematics. But he tells us that there may be other ways to know about the mathematics that could be through manageable pebbles or stones or knots or inscription in a bone. This type of knowledge could also be reflected in structures like, for example, the monument of Stonehenge that I'm showing here. This monument is well known for all, and I present it here because it is important for the concept I have developed. The mnemonic factor is one of these tools that archaeoastronomy can be can use it to follow. This concept takes into account two facts: that there is a summer solstice shadow that is short in the north hemisphere, and a winter solstice shadow that is long. Then if we talk the winter solstice shadow minus the summer solstice shadow and divide this by the gnomon size, this blue gnomon here, then we have a factor that it is independent of the place we are talking about. It is dependent only on the latitude of the place and the obliquity of the ecliptic. This means the epoch it was calculated. Then with this simple concept, we can approach to new knowledge that the ancient cultures could have had. We assume that the movement of the sun was known as, for example, here in this picture, we saw aborigines of Kenya looking at the shadow and measuring it in order to know what is the length of the shadow, and maybe know when the crops needs to be elevated. We have then, with an upright gnomon, we can have ancient people knowing the movement of the sun and the mathematical knowledge about integers and unit fractions, the general concept of triangle at the same time. As I mentioned here, these are triangles, and the very concept of triangle could have come from this type of measures. Then with this knowledge, they can measure, or they can decide where to put a city or a place to grow, or simply to move from one place to another. These are the same comments. As I mentioned, I took this image of Stonehenge because it's very interesting here that the concept of gnomonic factor mnemonic factor came to me from the observation of this great trilithon here, and this small stone here, that is stone 11 in the array of the Sarsen circle. And this concept came to me for Stonehenge precisely because 4,000 years ago, the basic relation in between the great trilithon and the stone 11 was 300. This means an integer. And this was the very moment I had this begin a development of some ideas of how this could be important. The name of Stonehenge is recurrent, and here I show the stone 11 making A, stone 11, and the great trilithon B, and the relation in between them is that it is the stone 11 is pointing south, directly south, and then this means that the shadow of the stone could go beyond this trilithon and has to be measured with that. In this study I made about Stonehenge, I found that the whole 5 trilithons in the horseshoe can be identified as moments on the year and to make a Wessex calendar. But this is a matter more detailed that I'm not going to go ahead for this moment. The important thing is that, as I said, we assume that the obliquity of the ecliptic through the motions of the to the year and the change in the shadows of the gnomon could have been understood, not the explanation that it is the Earth turning around the sun, but only the fact that the sun makes with the gnomon cast different shadows along the year between one big shadow, the winter solstice shadow, and the summer solstice shadow. Knowing this fact with modern mathematics, we can obtain the latitude of the place where it is observed and the obliquity of the ecliptic that tells us about the era or the epocha we observe this measure. And then let me give you a very simple example of this. An example of how you can use the mnemonic factor to know is in the study of Shou B. Xuan Hing, that is a book written by Cullen, in which a translation of the Shou B is done and present different facts, in particular 2 main facts: that the summer solstice shadow is 1.6 chi, the unit, and the winter solstice shadow is 13.5 chi, and the gnomon size is 8 chi. With this information and the equations I showed earlier, we can find that the latitude of the place of the observation of this phenomena was 35-33 latitudes, and the obliquity was 2402, meaning that it's a date of around 2,900 BC. And the place is called Hining, one place I found in China, in Shandong, that has this. Then I can say that having this information, we can understand that this observation could have been done in that place. This is an example of how it could be. Then we'll talk about Pythagorean times. Let me take the 522 BC as the island located in Samos, where grew Pythagoras. Then the latitude was 37:45 minutes, and the longitude 26 degrees 39 minutes. And from this, it follows that the mnemonic factor is 1 integer and 3/5, almost 1.6 decimals. And this is a round number that could have been observed by Pythagoras if he knew about. This is important fact, and with the relation with other triangles like the sacred triangle. This is another places that no Pythagoras went was Babylon and Delos, Crete, and other places in Greece, as Crotona, for example, that is in present-day Italy. In these places, the mnemonic factors are also fractions known as the 2/3, that is important in the Egyptian culture, the 4/7 and the 4/9 in Crete. This could be the knowledge Pythagoras learned in that place, and could be also knowledge that could learn about the right triangles, rectangle triangles. Then from a very causistic point that the theorem, like the 345 or the one that appears in 60, 80, 100 that appears in the show B Swan Hing, these casuistics take a form of a theorem, and that is the right angle triangle, that the square of the hypotenuse is equal to the sum of the squares of the other two sides in the triangle. And this generalization of this concept took place in the mind of Pythagoras. I only give you to you some of the tools that could be a help for this concept, like the right triangle made by the gnomon, the shadow, and the ray of light, and the concept of the shadows of the winter solstice and the summer solstice. Thank you very much for your attention. I give my talk. I want to thank also Professor Xenophon Musas that invited me, and also the organizer committee for this second Pythagoras International Festival. The reference for some of the information are known. You can find here in my book, The Gnomonic Factor, physical aspect and paradigmatic aspect of this factor. And thank you very much, Efrosin, and thank you very much for all for your attention.